Hello students, in the last video you will have learned in physics, that is light energy, you will have learned about reflection of light, then you will have learned about laws of reflection of light. Now this is the second part of the lesson when I will be explaining about plane mirror and the image that is formed through a plane mirror and about characteristics of the image that is formed in a plane mirror. Alright? So in the previous class you will have learned that light is a form of energy. It is the only energy that can be seen. Then a sun is a major source of light energy, and there are other sources of light energy like bulb, candle, stars. These are some of the examples of sources of light. Right? Now you have learned about laws of reflection of light. So I'm going to show you all about how you draw and then explain the laws of reflection of light. Now suppose this is the mirror edge. Now a plane mirror is represented by just showing a straight line, drawing a straight line with edged lines like this. That means this is the opaque surface of the mirror and this top portion is the reflecting surface of the mirror. Now I'm going to show one ray of light which is incident over here. The moment I show an arrow here, that means the ray is incident on the mirror. This point is called as the point of incidence, which now these terms I have already explained in the previous video. Now about this, if you draw a straight line in such a way that it is perpendicular to the mirror surface, that line is called as a normal. Now according to the laws of reflection, you all know that the first law of reflection in fact states that the angle of incidence is equal to the angle of reflection. So I'm going to denote this by I, small I, which is the angle of incidence. Suppose the angle of incidence with respect to the normal, is 30 degrees. Then this ray, after hitting this surface, will emerge, will get reflected, will bounce back at the same angle. That is, if angle of incidence is 30 degrees, the reflected ray has to be shown at an angle of 30 degrees itself. Arrows are very important, so these arrows will tell you in which direction the ray is coming and in which direction it is going after reflection. So this is angle of reflection R. You have the incident ray here, you have the reflected ray. This is angle I, angle R. This point is called as a point of incidence. Okay, this is the surface of the mirror. Correct? Now what is the first law of reflection? It states that the angle of incidence is equal to angle of reflection. The second law states that the incident ray, the reflected ray and the normal about the point of incidence, they all lie in the same plane. This is what you all have already learned. Right? Now I'm going to show you all how to locate the image of an object through a plane mirror. Alright? We are going to consider two cases here. Case 1 is wherein you have a plane mirror. Case 1, you have a plane mirror And the object in this case is a point object. So if the object is over here, this is a point object. Now an observer is observing from here. So observer. So this is a reflecting surface. So the image of this point will be formed somewhere behind the mirror. So how do you locate the image in this case? If it is a point object P, it is a point object P. So using laws of reflection, in the first law of reflection, I am going to draw a line. That means rays are actually traveling in this direction. So using laws of reflection, light is traveling this way and then coming in this direction. So at the point of incidence, you find, suppose this is the normal, this angle has to be same as this angle. Incident angle of incidence has to be equal to the angle of reflection. Now in the same way, I am going to show you another point. Now there will be, from this point there will be many rays striking the mirror and then the observer can see those points. So I am going to show another point somewhere here. And again at the point of incidence, show a normal, and at the same angle you find the rays will reach the observer. Rays will reach the observer. Correct? Now I have to produce these in order for the image to be formed. The image will be formed somewhere in this plane, along this plane. So I am just going to show dotted lines. So when you produce these rays backwards, wherever both these rays meet, that is the point where the object will be. In fact, let me show it somewhere here. I have to produce these rays backwards in such a way that there will be one sharp point, and that is the point where the object image is of object O, image is formed. Right? So this is in case of, this is the first case where the object is a point object. Now suppose the second case is when the object is a larger object, like for example a pencil. I have an observer here observing. There is a pencil somewhat like this, which is placed. Pointed edge, right? So there will be many rays passing from the pencil. It hits the mirror and then the observer can observe. But light, as you all know, will travel shortest distance. So only those rays are to be considered which will travel the shortest distance. So I can show two rays starting from this point. And of course at the point of incidence they are going to follow the first law of reflection. So there will be one ray like this. And I am going to show another ray. I am going to show another ray somewhere here. Okay. So from this point there are two rays which I have shown. The same way from the tip, we won't be considering the middle one, from the tip also I'm going to show two more rays. It follows the laws of reflection of light. And another one. So when you produce these rays backwards, when you producing them backwards, you're going to get a point somewhere here. You're going to get a point somewhere here. That means this position is this position, correct? And when I produce these rays backwards, they are also going to meet at one point. So when I produce them backwards, they also, so this tip will be somewhere here and this lower portion will be somewhere here. So the image will be formed over here. So far I have shown you two cases where the object is a point object and where the object is a larger object. Okay. Now we move on to the characteristics of the image that is formed in a plane mirror. Now what are the characteristics? So when you stand in front of a mirror, you can see yourself of the same size. Correct? So the first characteristic will be size is the same. As that of the object. Suppose the object is 1 meter in height, the image also is going to be 1 meter in height. Next, second characteristic will be distance between the object and the mirror will be same as the distance between the mirror and the image. Correct? Distance between the object and the mirror is the same as the distance between the mirror and the image. The third characteristic is the image will be a virtual image. Now what is a virtual? I'll come to that about virtual and real images. Virtual, it is, as I said, it is of same size. So it is something which is virtual, not real. Which is not real. And it is just an illusion. The moment you go off the mirror, you cannot see yourself through the mirror. Image cannot be seen. That means it is just as long as you are in front, you will find yourself to be reflected. Due to reflection, you can see your own self. And fourth characteristic will be image is upright. If you are standing straight, the image also will appear to be straight. So there are certain mirrors which are called as spherical mirrors, through which you can see for the certain positions of the mirror, you can see yourself inverted. So here it is real, here it is erect, image is erect or upright. And the fifth characteristic is there is lateral inversion when you stand in front of a plane mirror. Now what is this lateral inversion? Lateral inversion is when certain like certain alphabets appears to be inverted, right? Like when I raise my right hand, it appears as if the image has raised its left hand, right? So that is called as lateral inversion. Now, even on an ambulance, the letters which are printed, they will always be inverted. Now, what is the reason? It is so that suppose there is a vehicle in front, and the driver, when he sees those alphabets, that there is an ambulance behind, he can see them to be proper. Okay, through the mirror it appears to be proper, whereas if you look at it directly, it appears to be inverted, so that the vehicle can give way to the ambulance. This is just one example. Okay, so these are some of the characteristics of the image formed through a plane mirror. Same size, distance between the object and the mirror is same as the distance between the mirror and the image. It is virtual, that means something which is not real. Image is erect, and there is lateral inversion. Right? So now I am going to explain about real images and virtual images. So how are they different? What do you mean by real images and what do you mean by virtual images? Now, there are certain types of mirrors which produces images which are real. Now, what is this real? That means real images are those. Now, how do you differentiate between a real image and a virtual image? How are they different? Real images can be taken on a screen. So when you place a screen, you have to get a sharp image on the screen. So such images are called real images. Whereas virtual images cannot be captured on a screen. Such images are called virtual images. They are images here will be just an illusion. Okay, so it can be taken on the screen. On the screen, it cannot be taken on the screen. On the screen. Then real images are always inverted, upside down, right? Second difference is real images, they are always inverted. Always inverted. Whereas virtual images are always erect. Third difference will be the images which are formed on the screen in case of real images, they are produced by actual intersection of the rays. Light rays are actually meeting at that point to get an image. Such images are called real images. Okay? They are produced, they are formed due to actual intersection of light rays. Whereas virtual images are not formed due to actual intersection. You all must have seen in the previous two cases when to locate an image you just have to produce dotted lines backward. That means the rays are not actually meeting at that point. They are just being assumed to be produced backwards, and then that is how you get a virtual image. Okay, so they are formed not the in the backward direction. Due to producing of rays in the backward direction. These are some of the differences between real images and virtual images. Now in the higher classes you all will be learning more about real images. There are certain, as I have already said, there are certain types of curved mirrors which produces real images. Like for example, a pinhole camera. When you are using a pinhole camera to focus a distant object, the light from the distant object, it will actually pass through the pinhole and it will be formed on the screen. So such images are real images. Example. Whereas virtual is when you stand in front of a mirror, the image that is seen is a virtual image. Right? Now towards the end, I'll be explaining in this video. I'll be explaining about speed of light. Now, as you all know that light is something which travels fastest in air. And what is the speed of light? It is 3 into 10 to the power of 8 meters per second. This is the speed of light in air. So, now air is considered as a rarer medium. As the medium becomes denser and denser, you find the speed of light reduces. If you are considering water, if you are considering glass, slowly the speed decreases. Now the speed of light in water is less. It is around 2.25 into 10 to the power of 8 meters per second. It's less than 2.25, less than 3. Now if you consider glass, then it is still lesser because glass is much denser as compared to water and optically denser as compared to water and air. So it is around 2 into 10 to the power of 8 meters per second. So these are the values in air, in water and in glass. Remember that light, whenever it travels, it will always take the shortest possible path to cover a particular distance. It cannot bend around corners at all. So, the first law of reflection is based on this principle that light takes the shortest distance to travel. Right? Now, in this video, you will have learned about more about laws of reflection. You will have learned about image formed through a plane mirror, 2 cases. Then you will have learned about the characteristics of image formed in a plane mirror. Then difference between real and virtual images. Then towards the end I told you all about speed of light in air, in water and in glass. Alright. So in the next video you all will be learning about colors, about color addition and color subtraction. Thank you.